Alright, in this video I will be going over section 3.7. So let's go ahead and get started. So first of all, we're going to talk about arguments. An argument consists of two parts: the given statements, called the premises, and a conclusion. An argument is valid if the conclusion is true whenever the premises are assumed to be true. An argument that's not valid is called an invalid argument or a fallacy. A valid argument with true premises is called a sound argument. So you can have a valid argument when your premises are not true, but it would not be sound. Okay, so let's go ahead and look at testing the validity of an argument with the truth table. So here's the steps that we're going to use. So to test the validity of an argument, translate the argument into symbols. Write the argument as a conditional statement having the following form. So basically you have your premises and you want to see if those imply some conclusion. And so that's how you set it up. Premise and premise and premise. There may only be one or two premises, and then you'll have your conclusion. Construct a truth table for the conditional statement. If the conditional statement is a tautology, it means the last column you have all truths, then the argument is valid, otherwise it's invalid. So example 1, use a truth table to determine whether the following argument is valid or invalid. If a figure has 3 sides, then it is a triangle. This figure is not a triangle. Therefore, this figure does not have 3 sides. Alright, so first of all, we need to translate the argument into symbols. Alright, so here we have, if a figure has 3 sides, so let's call that statement P, then it is a triangle. We'll call that statement Q. So we have P implies Q, or if P, then Q. That's one of our premises. This figure is not a triangle, so this would be not Q. And so our conclusion, we write, this is the therefore symbol, this figure does not have 3 sides. So that would be not P. Alright, so just to make it clear here, I'm going to write P, a figure has 3 sides, and statement Q we'll say the figure is a triangle. Could say this figure is a triangle. So there's a little variation in what language, or I should say what wording we might use, but it should have the same basic meaning. Okay, so this is what we have. P implies Q, and we also have not Q, and then therefore we have not P. And so remember, 2 was writing conditional, or you have your premises with ands leading to a conclusion. So in this case we have, so this is basically step 2. We already did step 1. This was part of step 1. So we have P implies Q, and we have not Q, and we want to know if all of that implies not P. I'm sorry, not Q. So this is what we have here, our premises, which we put together with an AND statement, and we want to see if that leads or implies, oops, this should be not P. Okay, now we're good. So if you look at my truth table, this is our last statement. And so basically these are all the pieces that you put together to form that statement. All right, so let's go ahead and see if we get a tautology here. So we know P implies Q is only true when we have, or I should say it's only false if we have true false. So that's this case here where P is true and Q is false. So this is false. The others would be true. So again, it's only when we have true false that we get a false statement with a conditional statement. Now not Q is just the opposite of our Q column. So false, true, false, true. And so now we're putting these two statements together with an and. So we know an and statement is usually false. It's only true if you have two trues. So that's in this case here. True, true. Notice the rest of them, there's no more true trues. So these are each false. So finally, we want to see if this statement implies not P. Or if you have this statement, then we have not P. Well, let's see. I'm going to write... Did I do that wrong? No, let's see. Yeah, it looks like I made a mistake here. This should have been P. But I'm going to go ahead and put not, or I should say this should have been not P. We didn't need not Q. Or did we? Let's see. No, we did need not Q for here. But we didn't have not P, which we need here. So actually, I'm going to go ahead and put not P in right here. And so we would have false, false, true, true. Our not P column is the opposite of our P column. Okay, so finally, we're trying to see if this statement, this compound statement, implies not P. So it's only false if we get a true false. There are no true falses. And so each time this would be true. So this is a tautology. And so, let's see, that was step 3. And step 4, if the conditional statement is a tautology, then the argument is valid. So in this case, we would say the argument is valid. And that's because we got a tautology here, all trues. So it doesn't matter if P is true or false, P and Q, it doesn't matter. You have the 4 possibilities here. In every case, this statement will be true. All right, so that's how we do these. Let's move on to the next one. So it says, use a truth table to determine whether the following argument is valid or invalid. All right, so let me get set up here. Okay, so let's go ahead. We've got it's Friday. We'll call that statement P. It's Friday. Then I take my wife on a date. So Q, I take my wife on a date. So here you have if P, then Q, because this is statement P and this is statement Q. I am taking my wife on a date. So that's our second premise, and so that would be Q. Therefore, three dots, it is Friday. That's statement P. And so these are our two premises, and this is our conclusion. We want to see if this logic is valid, or this argument is valid. So I would encourage you to read this. If it's Friday, then I take my wife on a date. I'm taking my wife on a date, therefore it's Friday. Do you think that's a good logic or not good? Is that valid or not valid? Let's see if what you think is the case is actually true. So remember, this was all part of step one, basically writing this in symbolic form by by coming up with some statements. In this case, it's Friday and I take my wife on a date. So now step two is we got to write that conditional statement. So our premises are P implies Q, or if P then Q. And we also have Q. We want to know if those premises imply P. All right, so now we're going to figure that out using the truth table. And notice you can see in the truth table that is my last column. Excuse me. So here P implies Q is only false if we have true false. In every other case it'll be true. And then we want to know if this and statement is true or false. So we're basically doing Q and this, so these two statements here. Now remember, so we're only looking at these two columns. An and statement is usually false. It's only true when you're both statements are true. So here we have true, true. And here we have true, true. In the other cases, you don't have them both true. So true, true, and true, true. So there's two cases where we're true. Finally, we want to know if this statement implies P. So I like to put my P values in here, just to put it in order. But you could go backwards with an arrow here. I'm just going to go ahead and put my P values, true, true, false, false, just coming from the P column. So I want to know if we have, or if this statement's true or false. And again, it's an if-then statement. It's a conditional statement. It's only false when we have true, false. And we have true, false here. So that's false. Everywhere else we're good. There's no other true, falses. So these are true statements. So notice this is not a tautology. So we were supposed to determine whether the argument is valid or not. So we would just say invalid argument. Okay, so let's move on to the next problem. It's very similar to the one we just did, so I would encourage you to try this one and then watch the video. See if you've got it down. All right, let's see how you did. So Wesley studies for the test. We'll call that statement P. And then he will get an A. We'll call that statement Q. So Wesley, or you could say he, will get an A. That's statement Q. So this is P implies Q, or if P then Q. If Wesley doesn't study for the test, so notice that's not P. he will get an A. Let's see. He will get an A, that's statement Q. Or let's see, if Wesley doesn't study for the test, that's not P. He will get an A. That's Q again. So here we have another if-then statement. Now notice the word then is not here, but this is really an if-then statement. If Wesley studies for the test, then he will get an A. I probably should add the then in there. So if he doesn't study for the test, that's not P, then he will get an A. That's Q. Therefore, that's my 3 dots, Wesley will get an A on the test. So that's Q. So again, I would encourage you to read that and see if you think that's a logical conclusion based on the premises. All right, so that was all part of step 1. Step 2, we need to write the conditional statement with our premises. So we have P implies Q, and we have not P implies Q. And we want to know if that implies Q. And so you can see that's our last column here. Okay, so P implies Q. It's just like the one we did up here, up above. You should have, let's see, for true, false, we have false. The others are all true. For not P, this would be false, false, true, true. Not P implies Q. So we're basically going from here to this column. So basically in the opposite order. So be careful, we're not going this way. We're going from right to left. And we know that this is false if we get a true, false. So again, I'm only looking at these 2 columns. I have false, true, false, false, true, true, and true, false. So this is the one that's false. Remember, I'm going from right to left. So true, false, true, true, false, 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 true. There's only one true, false. And that's when we have not P implies Q. Okay, so these are true. So then we have this statement and, we have this statement here and this statement here. So it's these 2 here that we're going to do an and with. So we'll be looking at these 2 columns. So we know an and statement is only true when we have true, true. So we have true, true here and true, true here. Looks like that's it. So here will be false and here will be false. Again, an and statement is only true when we have true and true. And we have 2 of those. Okay, so finally we want to know if all of this implies Q. So again, I'm going to put Q in right here. This is the way I like to do it. So true, false, true, false. So an and this is a conditional statement. We know that it's false when we have true, false. So we have true, true, false, false, true, true, and false, false. Notice there's no true falses. So these are all true. So this is a tautology. And so this was step 3. And step 4, remember, we need to determine if the argument is valid or not. And so we have a valid argument here. Okay. Let's move on to the last page. Oops, sorry about that. Use a truth table to determine whether the following argument is valid or invalid. Now you'll notice this one, first of all, you're going to have 3 statements. I go to the beach. I swim in the ocean. Here's another, I swim in the ocean. My eyes get red. So there's my P, my Q, and my R. So P, I go to the beach. Q, I swim in the ocean. And then R, my eyes get red. So you're going to do the same thing you did before in the last problem, but notice this time you have to build the chart or the truth table. So again, I would encourage you to see if you can do the problem and then watch the video. All right, so let's see how you did. So this was statement Q again. So here we have an if-then statement. So we have P implies Q, or if P then Q. That's one of our premises. And then we have if I swim in the ocean, so that's Q, then my eyes get red, that's R. So Q implies R. Those are our premises. So therefore, there's my 3 dots. If I go to the beach, so we have another if-then statement. If I go to the beach, that's P, then my eyes get red. So P implies R. Okay, so this is our 2 premises, and then that's our conclusion. So this was all part of step 1. So step 2, we got to write down our premises, separated by an and these should each be in parentheses. And we want to know if all of that leads to the conclusion that P implies R. So that should also be in parentheses. So we want to know if these premises, these 2, imply this conclusion. Again, that's an if-then statement. So that's going to be our last column here. So you can see that first of all, we're going to need to know our truth values for P implies Q. You might want to write small here because we have a lot to do here. And then Q implies R. Oops, hold on just a second. So then Q implies R. And then we want to put those together with an and, so these 2 columns together. So P implies Q, and Q implies R. And then finally, we want to know if that statement implies P implies R. So we actually need P implies R here. We don't have that. So now we can put it all together. P implies Q and Q implies R. We want to know if that implies that P implies R. All right, so P implies Q. We're going to be looking at the P and the Q column. For remember, it's only false if you have a true false. So we have a true false here, so that's false, and a true false here, and that's it. So every other part, I should say every other case, will be true. Q implies R, so now we're using these 2 columns, and we're looking for the same thing, true false. So true false here, that means this statement is false there and here. I don't see any other true falses, so the rest of these are trues. So now we're going to do an AND statement with these two statements here, these two if-then statements. That's what we have here. So an AND statement is usually true or false. It's only true if you have true, true. So we have a true, true there and here and here and here. All right, so true, 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 and true, true. The other cases are false. So P implies R, so we're looking at these two columns, and we're looking for true, false. There's a true, false, so that's false. Another true, false, so this is false. And that's it. Everything else will be true here. So finally, we're working with this column and this column here. We want to know what this statement implies this statement here. That's what was going on here. So again, it's only going to be false if we have a true, false. So true, true, false, 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 true, true, true. I don't see any true falses. So there are no false cases because we don't have any true falses. So this is true in every case. So what we've just done is step 3. I'm sorry, I might have gone off the grid a little bit there. Get yourself caught up if you weren't able to see. You can always stop the video. So finally, step 4, we would say this is a valid argument. And it's because of the fact that this is a tautology. No matter what P, Q, and R truth values are, no matter what the truth values are, you always have that this statement is going to be true. So that's a tautology. It means this argument is a valid argument. We basically took an argument that was in words, we put it in symbols, and we used that truth table to determine whether or not the argument is valid. You can actually do this with very complicated arguments, but anyway, we're just doing a basic introduction here. That's going to be it for this lesson. If you have any questions, let me know.